So under introduction, the objectives are describe the entire course objective and then explain the Oracle database architecture, right? So I think in the previous session we saw what the course objectives are. That is how to install, create and administer your database, right? Then configure your database for an application, how to employ basic monitoring procedures, then implement a backup and recovery strategy, right? That is pretty important because your database will face failure at some point. So that time you must be ready to recover any data that is lost. And then how to move data between databases. Okay, so this is the entire course objective. Now when we come to talk about Oracle database architecture, first you need to understand what is grid architecture, right? What is a grid? Now when you call this database, on database 10G or 11G, that what does that G stand for? G stands for grid computing. Okay. Now what do you mean by a grid? Grid is basically a group of similar components that are working towards a common task, right? Or common goal. For example, in very common terms, you have electricity grid, right? Where all the houses or all electrical components are connected, right? With the help of a network. So they're all using electricity, right? So that is something common for all of them. When it comes to IT, when you talk about servers and you talk about a grid, so grid means a group of systems that are grouped together to perform a particular tasks. Okay. Now earlier, when there was not much of IT, I'm talking way back, not maybe 10-15 years back. So you had a lot of less IT operations, right? I mean, companies were doing their work manually. For example, you consider a bank. Everything was manually done, right? You had big ledger books, all the transactions were written down, balance was calculated, and everything was done manually. Now, as gradually IT, evolved, I mean, as more and more processes got digitalized, so they were dependent on your IT operations, right? Now you have internet banking, you have ATM machines. Now there's an upgrade. So everything is automatic. So as soon as you withdraw cash from the ATM machine, your account gets deducted. Okay. So what has happened is, from earlier days, the IT operations, increased, right? So when the IT operations increased, the dependency of the business process on the IT operations also increased, right? So earlier there was a single machine which handled all the operations, right? Your application, database, storage, everything was on a single machine. Okay. So users connected to that and they work. So amount of data processed was also less, and the amount of workload was also less, right? But gradually, as more and more, right. So as I was telling, the single server, previously was able to handle everything, but as in the workload increased, it was not sufficient, right? And as more business processes were dependent on your IT processes, reliability of the system was also, was more important, because if that system went down, your business operations stopped. Okay. So dependency on the server also increased a lot. So there are two things now. One is reliability and scalability. That is to handle more workload and to be reliable, right? That is, it should be up and running all the time. Now to overcome these two issues, what happened is, first thing, reliability. Instead of one machine, you have now they put a backup machine. Okay, so in case one went down, the other one immediately carried from that point onwards. So there is no downtime. Okay, so reliability is addressed there. Next issue was scalability. How to handle more workload, right? How to efficiently handle without any slowness or any other issues. So what they did is, instead of one machine, they grouped all the softwares that were running on that machine, right? They grouped all the application related software, they grouped all the database related software, and all your storage was grouped, right? So, and they installed each of them on a single different machine. Like all your application related software was installed on application machine, right? Or different server. Then they took another physical server and installed all your database and the related softwares. And on the third server, all they did was just save data, storage, nothing else. No operations are performed there, only saving data. Okay. So instead of one single machine, now you have 3 machines. One for application, one for database, and one for storage. Okay. So that is also known as a 3-tier architecture. Okay. And again, each is an individual machine. So to increase reliability, they had multiple machines, right? You have at least 2 to 3 application servers running simultaneously, 2 to 3 database servers running simultaneously, and couple of storage machines saving your data. So in case one went down, the other one can continue the work for you. Okay. So they were all grouped together. So they were all in a grid of its own. Like application servers were in an application grid, all the database servers were in a database grid, and all the storage servers were in a storage grid. Okay. So with Oracle came out with softwares to support each of this grid, right? If you want to build application grid, you can use the software called Oracle Streams, which is provided by Oracle. For database grid, you have real application clusters, and for storage, you have automatic storage management. Okay. So these are different softwares from Oracle to support each grid, right? And to control all of them, you have one single tool called as Oracle Enterprise Manager Grid Control. With this single tool, you can manage all the different grids: storage, application, and database. You can manage all 3, right? Now, why Oracle is famous? Because it is comparatively low in cost, provides very high quality of service, and it is pretty easy to manage compared to others. Okay. Now, this grid architecture, it didn't come up all of a sudden. Okay, it gradually evolved, right? So there is a committee called as Global Grid Forum that developed the standards for grid computing. Okay, it comprises a set of committees and working groups that focus on various aspects of grid computing. So that means different people from different backgrounds have come together and helped this grid evolve. So working groups and committees are composed of participants from academia, research community, and increasingly commercial companies, right? So as I say, some are from the research department, some are from the commercial companies, some are from academics. They've all come together and helped this grid architecture evolve. Okay. Grid computing can achieve the same very high level reliability of a mainframe computing. So mainframes are very high reliable, right? And they provide a top performance. Okay, mainframes. So your grid provides the same very high level reliability as a mainframe because all the components are clustered in a grid. So that means even if one server fails, the other server can continue the work, right? So you are achieving the same high level reliability as a mainframe, whereas mainframes are very expensive. So grid computing is very cheap, right? Like mainframes and Unix symmetric multiprocessing servers that are your huge mainframe servers. Grid can be built with open system technology such as Linux OS and Intel processors at a very low cost. So mainframes are very expensive, whereas grid can be built with open source technology, that is freeware, right? Software that are available for free. That way your grid cost will drastically reduce compared to a mainframe. So that is one of the key reasons why grid is very widely accepted. Okay, right. So that is about the grid architecture. Now we'll discuss about database architecture. Now when you take a single server, database server, in that you have database installed, right? Now database has an architecture, right? There is a particular structure for it, how the data flows and how the data is processed and everything, right? There's a pattern, there's a structure there, right? So as a whole, a database server is basically an information management system, right? So you can manage your data that you're saving there. Okay, so it basically consists of 2 components. The first part is called as an Oracle instance, and the other one is called as an Oracle database, right? Oracle architecture mainly has 2 components. First is called as Oracle instance, and the other one is called as an Oracle database. So first, what do you mean by Oracle instance? Now to explain that, say for example, in my laptop, this is the operating system is Windows, right? At this point, there are these many applications running. There is one GoToMeeting, there is a Microsoft Outlook, there is an Excel sheet open, there is a PowerPoint running, and some couple of folders running. Right? These are the list of applications that are currently running. And each application has a process associated to it. Now for example, this Outlook.exe is the process, and it is taking some amount of space to execute, right? Some amount of memory, the 45,704 KB, right? This is the memory that is just consuming. This memory is provided from the main memory of my system, that is the RAM. Now how much RAM do I have? If I go to the system settings, I can find out, right? So my system is running currently 4 GB of RAM, right? The amount of memory is there is 4 GB, and out of the 3.75 is currently usable, right? So out of that 3.75 GB, 45 MB, okay, if you convert this, it will be 45 MB. So 45 MB is being allocated to this outlook.exe file, outlook.exe application, okay. Now if I close this application, right, this process will stop executing, okay. They are directly dependent. Each application that is running is dependent on its process. So if I close this process, this application will stop. Now if you can observe here, I will close this outbox. See, this process will vanish from this list. See, it is gone. Now Outlook is no longer available, right? Similarly, say I will close this Excel, okay. I will terminate this process, okay. I will select this and click on end process, okay. It is asking, one second. Right. Okay. Now what I'll do is I will close this process, right? I'll end this process. So the application automatically closed, right? So once I terminated the process, the application also closed, right? So that means the application that is running is directly dependent on its process, or to say, application requires this process. So whenever I start that application, a background process will start to execute to support that application, okay, and that background process will take some space. This space is provided from the main memory of the system, that is RAM, okay. So the combination of this particular background process called whatever background process is here, and the amount of memory it is consuming, right, both of them put together is called the instance of that application. Now if I take this application Outlook, so sorry, not Outlook, this is PowerPoint, right? PowerPoint application, this PowerPoint.exe and 17 MB of memory both form the instance of that application. So if the instance is available, that means the application is up and running. So if I close this instance, application is no longer available, okay. Similarly, for your Oracle database, when your database is up and running, that means the instance is available, right? There are a set of background processes running. So since Oracle is a very complicated software, not one single process is not sufficient, okay. There are some 150 background processes that are running, and each background process will consume some memory, okay. So that means like this, you will have Oracle application open. For that database, now you will have a list of background processes running, and they'll all consume some memory. So the combination of this background processes and the memory is called as instance of your Oracle database, okay. So that is the first component, Oracle instance. Second one is called as Oracle database. Now database, now for example, in the previous this we saw, say for example PowerPoint. So PowerPoint is an application. This application will have some files created somewhere, right? For example, see here, C drive, program files, Microsoft Office 12. So if I go to that location, I will find some files there, right? Say for example, C file, C drive, program, Office 12. So these files are related to my Outlook, PowerPoint, right? So when I installed PowerPoint in my system, so these files were created, right? Similarly, when I install Oracle software, there are a list of files created, okay? So you can see here, these are the files, right? So whenever you create a database like this, some files will be created. So all those files put together will form the second part of your database called Oracle database itself, right? So instance is more logical because it is all processes executing and the amount of memory they have consumed, and database is the physical files, right? Physical structure. Okay, so these are the two components in your Oracle database server that make up your database architecture. Now here you can understand in this picture, the first component is your Oracle instance, which is a combination of memory allocation and the background process. So the term used for memory allocation in Oracle is known as system global area. You don't call it as memory allocation, you call it as system global area. Okay? And background processes. So these two put together forms the instance of your database, first component, and all the physical files that are created when you create a database form the second component of your database, that is database files. Okay? Right. So instance is only available when your database is up and running, right? Because once you shut down your database, your instance is no longer available, because as we saw in the example, when you stopped that process, the application was no longer accessible. I mean, it stopped, closed. Similarly, when you manually close the application, the background processes stopped executing, right? So they are directly related. So when your database is open, instance is available. When your database is closed, instance is no longer available. Okay? So here you can see each running Oracle database is associated with an Oracle instance. Now I have to emphasize on this keyword running, because only when your database is up and running, then your instance is available. If your database is shut down, our instance is no longer available. Okay? So each running Oracle database is associated with an Oracle instance. So when a database is started on your database server, Oracle software allocates a shared memory area called the system global area. Right? So there is a memory allocation happening for that background processes to execute, right? And that term used for that memory allocation is called system global area, and starts several Oracle background processes. So the combination of SGA and the Oracle process is called as an Oracle instance. So that is the first component of your database architecture. So after starting an instance, the Oracle software associates the instance with a specific database. That means these processes that are executing, they must relate to some physical set of files, right? Now, for example, when I've opened this PDF, I mean not PDF, this PPT, we can see all these slides, right? That we are just referring to. So this data is physically saved. So when I open the application, this PowerPoint application must access those physical files. Only then I can view this data, right? Now, for example, if I open this slides here, there are so many PowerPoints available, right? When I open this PowerPoint, particular PowerPoint presentation, that PowerPoint presentation application will run, and that application is accessing this file, the information saved in this file. So these are the slides that are saved, right? Similarly, when you open your database, the instance will start, and that instance has to be mapped to some physical set of files where you have saved your data, right? So that association is known as mounting the database. So without mounting, you cannot access whatever data you have saved in your database. Okay? The database is then ready to be opened, which makes it accessible to authorized users. So multiple instances can execute concurrently on the same machine, each accessing its own physical database. That means you can install multiple databases on the same machine, but you need to have enough memory to support instance of each database. That means enough RAM to support all of them. Okay? Right. Generally, multiple databases are not required, because a single Oracle database can help or can process huge amounts of memory, like 5 TB, 10 TB, terabytes, that is 1000 GB of data can be processed by a single Oracle database. So you really don't require multiple databases running on the same machine. So you can look at your Oracle database architecture as various interrelated structural components. That is because the memory allocation that we were talking about, that is your system global area, has been categorized as memory structure. All the background processes put together have been categorized as process structure, and all the physical files that are created have been categorized as storage structure. So that's why you can look at your Oracle database as various interrelated structural components, right? These are all dependent on each other. So Oracle database uses your memory and process structure to manage and access the data inside your database. So to access data in these files, you require these two structures, memory and process. Okay? All memory structures exist in the main memory of the computer that constitutes the database server. That is the RAM on that machine, right? So the entire instance is in your RAM. Okay? So even if you shut down your system, the instance is no longer available, because there is no data in RAM. RAM is all temporary data, correct? Hard disk is permanent, whereas RAM is temporary. So whatever data is in your RAM will be lost when you shut down your database, right? So that is why you have these physical files where you save the data. Okay? And processes are the job that work in the memory of these computers. So a process is defined as a thread of control or a mechanism in an operating system that can run a series of steps. Right? So this is basic program. A process is basically like a program that is constantly running. So in the example where we saw Outlook.exe, PowerPoint.exe, right? So those are the background processes. Similarly, Oracle will have one, Oracle.exe. But a single process is not enough because Oracle is a very complicated software. There are close to 150 background processes executing, okay, when you start your Oracle database. So those are the two components, right? Oracle instance and Oracle database. Now, your instance, when you consider instance or when you consider memory structure, there is a lot more to it, right? It is not just system global area. When we talk about memory structure, there are several smaller components that actually group together to form your system global area. System global area is not one single unit, it is a group of smaller units all combined together is called as system global area. Okay? So as you can see on your screen, there are two types of memory allocations happening. One is system global area and the other one is called as program global area, SGA and PGA. There are two types of memory allocations. I mean, I know earlier we said there is only one called SGA, but there are actually two. One is called program global area, the other one is called as system global area, right? Now earlier I told you there are about 150 background processes executing, right? So each background process has its own private memory allocation, right? For it to execute, it will consume its own memory, right? That is provided from RAM. That is not used by any other process. So that small memory allocation is dedicated to that process only, okay? That is known as PGA, right? So all those 150 background processes have PGA of their own, and on the for a common memory, where they need to access, they have system global area. Okay. So system global area is shared by all the processors. So that is a very big memory allocation that is shared by all. Whereas program global area, it is a small memory allocation that is private to each of those background processes. Right. Right. SGA is the memory area that contains all the control information of that instance. So how that instance is performing or what data it is processing, everything is in your SGA. Okay. Right. So as you can see, SGA is made up of smaller components like shared pool, streams pool, large pool, Java pool, database buffer cache, and redo log buffer. So each component has a specific, it particularly saves a specific kind of data. Okay. Now when you say memory, it means it is saving some data, right? It is used to save some data, right? So shared pool is dedicated to save some kind of data. Streams pool is dedicated to save. Now since this is all part of your RAM, saving data is temporary, right? Once you shut down, whatever data is there in each of these components is lost. Okay? Right, so we'll see what each of those components are meant for. So first is your database buffer cache. Now the term database buffer cache, what does it mean? It is basically used to cache a block of data retrieved from the database. Okay. Now what do you mean by block of data? Now for example, let me use this as an example. Say for example, here say this is your RAM, okay? Your system RAM, say this is of some 10 GB in size, right? So in this RAM you have SGA, okay? SGA, one of the components is database buffer cache, right? Okay, now here you have your hard disk in your system. So hard disk has some data, okay? Data may be in the form of tables, but actually it is not saved as table. Now for example, when you save a picture, right, in your database, not in your database, when you save any data in your system, like for example, if I open this my computer, I have C drive and D drive. So if I go to say music, I have so much of music here, right? Now for example, there is some files here, sorry, right, these are music files. Now is it actually saved as a music file in the hard disk? No, This is saved in some other format that we cannot understand. That is called as a binary format, right? When we play this, when we execute this file, that is played through some application like your Windows Music Player or some MP3 player or any other player, it is converted into audio format and then given to us as an output through audio, right? Speakers. Similarly, when you go to any document, there are so many documents here. Now, if I open this, it is not actually saved as a text file, right? It is saved in some other format called binary format that is converted to us through this Word document, Word application. It is given to us in a readable format. So we can read the text there. It is converted into text format and then displayed to us, right? Similarly, when you save data in your database, it is not saved in the form of actual data, not tables. Database contains all tables, right? Rows and columns. So in your hard disk, it is not actually saved in the form of table. It is saved in binary format. Now, as a user, when you log in and you check when you want to find out some data, okay, as a user, say user 1, you log into your database and you type some question, okay, like what is the salary for employee Ram? Okay, so you put a question like this to your database. Now your database has to analyze this question. First it needs to go to the hard disk, find that information where this RAM data is saved, find out what that salary for that employee is, right? So say for example, name is Ram and salary is like this. There's one more user, okay? So like this I have saved some data here, okay? So it has to find out who this user is and what that information is, right? Now, it is not actually saved in this format, right? That is what I was telling you. So data is not actually saved in the form of tables and rows in your hard disk. It is saved in binary format. So binary will be something like this, 0, 1, 0, 0, something like this, right? All zeros and ones. This is how the information will be. Now this is not understandable. We cannot know what that means. Right? As users, we cannot understand it. So what your database Oracle does is, it will fetch this information, right? So say this RAM, this 1000 will actually be saved like this. Okay? So it will copy that information and place it in your database buffer cache. Okay? So here, data is saved in the form of data blocks. Okay? Data blocks are the smallest memory allocation, so each data block will have one set of information. So RAM is saved in one data block. This salary information is saved in one data block. There's one more data block holding this, right? So data block is the smallest component of your hard disk. So generally in your hard disk you have say 1 terabyte hard disk will be divided into different drives, C drive, D drive. Each drive will have sectors, tracks and then data blocks, right? Small components. So data block is the smallest one. So this data block is copied and put in your database buffer cache so that this information can be converted into user readable format. So this becomes 1000 and this 1000 is displayed as output for this user. So answer for this will be 1000. Okay? Or if you say which user, if you type a question like this, which user is or has salary greater than 900, okay, or you say salary equal to 1000. So it has to come back here, look for that information. Now there are two users, right? So Ram and ABC, okay, so it has to convert that name. So Ram will be something like this, sorry, there is no 2, 1010, right? And ABC will be something like this, right? So these two has to be converted into user readable format and the output will be given like this. Okay, so that is why your database buffer cache is used for. So it caches block of data retrieved from the database, that is the hard disk. So whenever users ask a question to your database, right, in any form, the simplest example would be Facebook. Okay, so you log into Facebook, that is the application. So your data is saved in your database somewhere in some other location, right? Like for example, when you want to see some of the photographs that you had posted earlier, that must have been saved somewhere, right? So when you click on that album and click on that picture, it will open up, right? It will come in a big full screen. That means that picture is being retrieved from the hard disk. So in your hard disk, it will not be saved as actual picture, it will again be in that 0 binary format, right? It will be in somewhere Facebook's database hard disk. So that will be retrieved, converted into a picture format where you can actually view it as a picture and display it to you on your web page as a picture. Okay, right. The next component is known as redo log buffer. Okay, now to understand what redo log buffer does, first we need to understand what redo log means, right? Okay, now first we will understand what the term redo means. Okay, for that I will open a WordPad. Okay, now for example, see, I am typing some data here. Okay, so this is some text data, right? Now what I am doing, I will select a few characters here. Okay, I will delete, then I will select a few here, I will delete, I will select a couple of more and delete. Now here on the top you see there are two options. One is called undo. So whatever I have done operation now, I have deleted 3 particular this thing, right? All those 3 will be undone. 1, 2, 3, right? So that's it. The last delete is all the text data that I have, all the text data is gone. So I'm back to the initial stage, that is the new document, because I just opened a new document and typed in, right? So what is my first operation? Typing in text data. So if I click on redo, all the data that I have typed is come back. So that is redo 1. The next redo operation what I did was delete these 2 characters. Those 2 are gone. The next redo operation will be the next 2 that I deleted and the next 2. So now you understand what undo and redo is. Undo means whatever I have done is undone. Redo means to again do whatever I had done previously, right? Okay, so this is undo and redo. So for undo, first you need to do some activity, right? So that is I'll type some data. Then redo is to undo whatever I have done. Okay, so now I'm redoing, that means all the text has come back. Then whatever operations I performed on those text has been again done, again performed, right? Similarly, for your database, what are all the changes that you are doing? Like for example, in the example, we saw you queried for the information whose salary was, whose name was Ram, or whose salary is equal to 1000, right? So information is in your database buffer cache that has been converted into user readable format and presented to the user, right? Now as a user, say you change this data. Say first you query for the information of salary, employee name Ram. So you will change this value from 1000 to 1500 and you will save. So in your hard disk the value will change from 1000 to 1500. So that is one activity that you have done, right? So now you have an option of undoing it. So if you undo, this 1500 will change back to 1000, right? So the first time when you perform the operation, so that is one operation that has been performed, that is changing the employee value, salary from 1000 to 1500. Next, like this, some other user will perform some other activity. User 2 will do some other one. So user 3 will do something else. So all that list of activities that are happening, right? They are all made a note in your database. Okay, there is a file called redo log file. So that redo log file will keep a track of all the changes that are happening to the data in your database. Now why do you need to keep a track? In case if you want to re-perform all those activities, you need to have them noted down somewhere, right? So your redo log buffer is where the change is first written, right? So as you fire the query, change the salary for a RAM from 1000 to 1500, that change will be first noted down in your redo log buffer. Once the change happens, then it will be copied from your redo log buffer into redo log file, because in your buffer it is temporary. Once you shut down your data, it is lost. Once you shut down your database or your system goes down, the data is lost. So that is why it is copied into a physical redo log file where it is permanently saved. Okay, so why do you require this? In case you want to redo all the activities on your data in your database, you will have that list ready. Now what is the scenario where you will be using this? For example, say every day you take a backup of your database. At the end of the day, when everybody has finished their work, you take a backup of your database. Okay. So like that, yesterday also, say for example, yesterday evening also you have taken a backup. And say today afternoon your database has crashed. How did it crash? Say the hard disk failed. So you put a new hard disk. You remove the old one which is corrupted or gone. You put a new hard disk. Now new hard disk has no data in it, right? So what do? You bring back the data from the backup. So whatever data is there from your backup, you copy it to the new hard disk. But the backup is from yesterday evening. So whatever data now there is in your database is from yesterday evening. So what happened to the data? What has all happened? Changes that have happened on the data from morning till afternoon, because crash happened in the afternoon, right? There are two things. Then now you can do two things. One is you ask all the users again to redo their work from morning, or you can instruct your database to reapply all the changes that have happened since the backup till the point of crash. So if you instruct your database to do that, your database needs to have a list of changes that have happened, right? So that it can reapply one after the other, right? So that entire list is in your redo log files. Okay? So that is why your redo log buffer it temporarily holds that data as the change is happening. Once the change is done, it will write that information to redo log file. So these are two components of your SGA. Okay? Then you have something called a shared pool. A shared pool is basically used when the you remember each process to execute, it will take some space in your SGA, right? It has allocation here because the example that we saw earlier, each process that is executing will take some memory. Like that, each user who's connecting to your database will also require some memory, right? Each user has a process. That process will take some memory. Okay, that is provided in shared pool area of your SGA. Okay, so if there are 100 users, 100 processes will be there for each user, and each process will take space from the shared pool area of SGA. Okay. Then you have large pool. Now a normal user operation will not require too much of memory. Small amount is enough. But there are certain operations which deal with large amount of data. Like for example, when you're taking backup of your database, the entire data in your database is accessed, right? You need to copy all the data. So that kind of operation requires more memory to execute. So your shared pool will not be enough. So you have something called as large pool, which will provide that extra boost of memory that is required. So generally a DBA will connect and use memory from large pool area, whereas a normal area, shared pool area is enough. Then you have Java pool. So when you connect your database using a Java based application, so that process takes space from your Java pool. And there are some Oracle developed applications like Enterprise Manager and SQL. So when you connect using these two applications, memory is provided from shared pool area, right? Okay, so that is about the memory structure. So these are all the components: shared pool, stream pool, large pool, Java pool, database buffer, cache, and redo log buffer. Now when you are defining memory for your database, I mean when you are creating your database, you need to define how much of memory you are going to allocate. Okay. So there is a parameter called SG_target. So you need to define that to set this memory. Okay. Say for example, you have 10 GB of RAM. How much of this 10 GB you want to allocate to SGA? So the ideal value is 40%. Okay. So that will be 4 GB. Out of this 10 GB, 4 GB is the ideal value. Okay. If you give more than that, because this 10 GB is used for your entire operating system. So now Oracle is a application. It is like an application that is running in your operating system, right? It is another program running in the operating system. So your operating system also requires this RAM, right? So without that, your Windows will not start. Without RAM, your Windows will not start, right? So on your Windows, you are running Oracle, right? So Oracle is another application like this. Here you see there is a Word document, GoToMeeting, Excel, PowerPoint. Like this, Oracle is one more for your Windows. Okay. So out of this 10 GB, up to 40% you can allocate to your SGA. Okay, that is almost up till 4 GB when you are using 10 GB of your RAM. And there is a parameter called SG_target. Okay, so you will set SG_target is equal to 4 GB. So that 4 GB is automatically distributed among shared pool, stream pool, large pool, Java pool, buffer, cache, and redo log. It is automatically distributed. You do not have to worry. But if you do not use that parameter SG underscore target, then you have to set this value individually for each of these parameters, right? For shared pool, you have to set say 1 GB, for stream pool half GB, for large pool 2 GB. You have to individually set for each of them, and that is not recommended, okay? Because you may never know when you might require memory, right? When this might run out of memory. When you set that 4 GB, it will automatically distribute it. So as and when required, it'll reallocate memory to make sure that all the components have sufficient memory. Okay, so you do not run out of memory, right? So Oracle recommends you to use SG underscore target parameter. Right. That is about the storage structure.